The purpose of the video is that I'm going to create a screencast of using a technology tool while investigating my task. In other words, I'm going to illustrate how to use a technology tool to investigate statistics questions. Also, I'm going to use advanced and powerful features of a tool to go in depth into an analysis. In this video, I will try to be statistically accurate and to apply statistical habits of mine. The task is a sample of 157 roller coasters in CodeApp. As a preview, I will use real-world data to investigate and engage students to learn key concepts in data and also statistics. I'm going to use those 157 roller coasters from US parks from the past 100 years, and attributes such as top speed, material use, seating arrangements, etc. will be used to make sense of the data. And finally, mathematical content standards are NC statistics and prob standards for 6th to 8th grades, which are NC6 SP1, SP2, SP4, and NC8 SP1. And also I have NC statistics and prob standards for math 1 grade, which are NCM1 SID1 and NCM1 SID6. So we can have the following questions as investigate the following questions related to how fast roller coasters tend to be. So we are going to work on the top speed of roller coasters. And the first question asks that, are there any differences between the top speed of roller coasters in older, newer, or more recent eras? And as you can see, we have one numeric attribute, which is top speed, which we are going to investigate in 3 different categories as older, newer, or more recent coasters. So let's go to CodeApp and find out. So here I have a graph and I have a table of data. So I'm going to use the top speed and drag it here in my graph. Okay, so in my graph, as you can see, I have the data for 157 coasters as the table mentions. So I'm going to examine if there are all the data here in my graph. So I'm going to use count. You can see that I have 146 data here. So I can conclude that there are 11 missing data for top speed. And you can see that here, for example, I have one missing value, and here. You can find all of the missing values from the table. Okay, now I'm going to find out the mean of the data of 146 data. As you can see, the mean is 58.64. I'm going to use a movable value and put it on the mean. For next steps, I can compare the mean for different groups with the mean 146 coasters, which is here. Okay, now I can add percent to see how many coasters are faster and how many of them are not faster than the mean. Then you can use the median, and as you can see, there are only 3% difference between the mean and the median, which is a good criteria to examine if the data is normal or not. Then I can use box plot. Box plot gives me very good information about data. I have Q1, I have minimum, I have Q1, I have Q2, Q3, and also maximum. Moreover, it shows me that I have 4 outliers here and 2 outliers here. So for the total of 164 values, roller coasters, I have 6 outliers, and I'm going to examine if these 6 outliers will exist when I'm going to categorize the data or not. And let's go to find out what will happen if I add age group as a layover to my graph. Okay, you can see that I have 3 different categories: older, recent, and newest. But here from this graph, I cannot extract enough information that how faster are coasters in different age groups. So I'm going to drag age group here. So as you can see, the 58.6 is the mean for all the data together without any hierarchy. But if I put them in 3 different groups, you can see that the mean for the older coasters is 49, and the mean for recent coasters is very close to the mean for all the coasters, is 58.07, and for the newest coasters the mean is 66. So you can see that the newest coasters are faster and older coasters are not very fast, but the mean for recent coasters is very close to mean of all the coasters. So let's go to next questions. The next questions ask that does the type of material make differences in the speed or not? So I'm going to work on the category of type of material. So here I do have type, which are wooden or steel. I'm going to overlay here. Okay, we have extract one information from this data and graph. You can see that in older coasters the majority of coasters are made of wooden, and in recent one you can see 50-50 of wooden coasters and steel coasters, but for newest coasters you can see the majority are from steel. Also for outliers you can see that here we have 5 outliers. However, we had 6 outliers when we analyzed all the data together without any categories. So one of the outliers is disappeared here. It means that this is not outlier when you are going to separate data into 3 different categories. Okay, I'm going to substitute these two, and I'm going to examine if the type really matters or not. Okay, let's go to analyze the outliers. Here we have only 3 outliers, one for steel outliers and 2 for wooden outliers, while we are going to work on top speed. So you see that I have half of the outliers gone for when I'm going to analyze top speed based on the type. And also you can see that the mean for steel coasters is more than the mean for wooden coasters. Also the mean for steel coasters is more than the mean for all the coasters which we are analyzing them together. So the type really matters. And for the third question, it's asked if you were going to ride a coaster that was built before 1980, what would you expect for a typical top speed? What about if you were riding a new roller coaster? So it asks us about the time. So I need to add another attribute to my graph, which is this one. We can consider year opened as a categorical data or as a numeric data. It depends on how you are going to analyze, but here I'm going to use that as a categorical data, and you can see that I have 1, 2, 3, 4, 5 different categories for the time or year which the coaster is opened. And you can see that if I remove this one, I can have a better analysis. Okay, so you can see that the older coasters are not enough fast. As you can see, almost all of them are before the mean and also the median. And for these coasters, we have very close coaster. The mean of top speed very close to our mean. For the next generation, I have a population of coasters which are below and upper the mean. For this category, I have most of the coasters which have top speed more than the mean, and for the last category, which are very new coasters, I see that the majority of coasters are here more than the mean of top speed of the total of coasters. But it asks that for the coasters which are before 1980, what do you think? I see that for these coasters, I can use my table. You can see all of them are before 1980. I can easily see that for these coasters, the top speed is less than 58 or 60, but for the coasters after the 1980, I can see that coasters are so much faster.